When we think about the end of the universe, our minds usually jump to events that are billions or even trillions of years in the future. The Big Rip, for example, where the accelerated expansion caused by dark energy will eventually tear apart all cosmic structures, or the Big Bounce, a hypothesis suggesting that the universe goes through cycles of expansion and contraction, with the current universe being just a phase of expansion in an eternal cycle. These are the kinds of theories we imagine happening long after the Sun and Earth have ended their existence. However, there is a quicker, and unfortunately more treacherous, way for everything to end: vacuum decay. And the worst part? It could have already happened, and we wouldn't even know it. Let's dive into this fascinating and somewhat frightening idea by understanding what vacuum decay means, how it works, and why it's considered a kind of self-destruct button for the universe. Let's start with the basics: energy. While it's tough to define energy in simple terms, we all have a sense of what it means. Energy is everywhere and necessary for everything. From powering your phone to allowing you to take a walk, your body and the world around you are in constant transformation of energy. One of the fundamental principles of physics is that energy cannot be created or destroyed, only transformed. One interesting thing about energy is that everything in the universe seems to always want to settle into the lowest energy state possible. Think of a roller coaster. When the car is at the top, it has a large amount of gravitational potential energy. As it moves downhill, that energy is converted into kinetic energy, and the car only comes to rest when it reaches the lowest point, where its potential energy is minimal. This same principle applies to almost everything in the universe: atoms, subatomic particles, quantum fields. They all want to reach the lowest energy state possible. The energy of the universe isn't just found in visible things or objects we can touch, like a ball rolling downhill. It also exists in more abstract forms, such as quantum fields. These fields govern the behavior of everything in the universe, from how particles of light, known as photons, move, to how quarks come together to form protons and neutrons. At their core, these fields are the fundamental rules that dictate the structure and functioning of the universe. These fields also seek the lowest possible energy state, a state we call the quantum vacuum. The name might sound contradictory, but the vacuum isn't an absolute nothingness. It's simply the lowest energy state possible, where no significant particles or excitations are present. As long as the universe remains in this stable state, everything continues as we know it. However, there is one field, in particular, that gives us some concern: the Higgs field. The Higgs field is fundamental because it's responsible for giving mass to particles. When you hear about the Higgs boson, also known as the God particle, it refers to an elementary bosonic particle predicted by the Standard Model of particle physics. The Higgs boson was theorized to have emerged shortly after the Big Bang as a massive particle, predicted to validate the current Standard Model of particles, and was tentatively confirmed on March 14, 2013. It holds the key to explaining the origin of mass in other elementary particles. All known and predicted particles fall into two categories: fermions, which are particles with half-integer spins, and bosons, which are particles with whole-integer spins. Without the Higgs field, particles wouldn't have mass, meaning atoms, molecules, stars, and even we ourselves wouldn't exist. Here's where things get tricky. Scientists expected that the Higgs field would be in its lowest possible energy state, meaning the universe as a whole would be stable. However, measurements made after the discovery of the Higgs boson suggest that it might not be in this stable state. Instead, the Higgs field might be in what we call a metastable state. It appears stable but is actually just temporarily in a low energy point. There's a lower energy level where the Higgs field could settle, but it hasn't reached that point yet, or at least, not yet. If the Higgs field were to decay to this lower energy level, the physics as we know it would change instantly. Imagine being at the top of the roller coaster again, but this time you're not secure. A small push, and you suddenly plummet to an even lower level. That's vacuum decay. The Higgs field could release enough energy to trigger a devastating chain reaction, a bubble of destruction expanding at the speed of light, fundamentally altering the nature of matter. Atoms, particles, and even the fundamental forces that govern the universe would stop functioning in their usual ways. Practically everything we know would be destroyed, quickly and efficiently. If it were headed our way, we wouldn't even know it until it was too late. There would be no time for alarms, reactions, or escape plans. In an instant, everything would simply cease to exist. This might sound terrifying, but there's one detail that offers some comfort: the universe is vast. Because of the accelerated expansion of the universe, there are parts of it moving away from us faster than the speed of light. This means that even if one of these bubbles of destruction were generated in some distant corner of the cosmos, it might never reach us. Additionally, since the universe has already gone through extremely energetic phases, like the Big Bang, many scientists believe that if the Higgs field were truly unstable, something would have already happened by now. Even though the chance of vacuum decay happening is small, it's still real. The Higgs field is on the edge, meaning there's a possibility that some phenomenon, perhaps a collision of highly energetic particles or some unforeseen cosmic event, could trigger the process. This is one of the most efficient ways to destroy the universe, almost like a reset button that could be activated at any moment. While the probability is low, science tells us that, in theory, this catastrophe could occur at any time, and we simply wouldn't know until it was too late. But until then, don't forget to subscribe to the channel to keep learning more about science and the universe with us. See you in the next video.